All right, good afternoon, everybody. This is Jeff from Math and Engineering Help Desk, and today I'm giving you a video of a video. This is a video that I recorded not too long ago. Some of you aficionados may have seen it pop up on my channel and then take down immediately. And the reason I took it down is because the audio did not encode properly, and therefore I am now going to do a voiceover of the video. So anyway, this is a video that's about point-slope form, and this is a little still of some facts about point-slope form and where it comes from. In this video today, I'm going to be walking through some examples on point-slope form and how to move between, writing it as well as how to move between certain forms, such as slope-intercept form and standard form. And I also want to spend some time going over some specific examples. So hopefully the timing of my dialogue will work with the timing of my video. So anyway, there's point-slope form. And what we're going to do is first we're going to do a few examples where we're writing some equations about point-slope form and using the y minus y1 equals m times x minus x1 format. Now you'll recognize this kind of comes from the slope formula, which is y2 minus y1 over x2 minus x1, which equals m. And this is basically a rewriting of that with x and y being any point and y1 and x1 being any particular point that you are trying to use. So if you want to use point-slope form, it's a quick way to write a linear function just from a point and a slope, which is the sort of the shortcut and benefit of it. So anyway, in this couple examples we're going to move some things around here because one of the examples is covered up. So do that real quick, and here we go. So what we're going to do is we're going to be writing some point-slope form formatted linear equations using some examples. So this first example, which is letter A, that's the point 3, 5 with a slope of 2. So when we write the point-slope form of this particular function, we're going to use the text tool to do so. And all we have to do really is just plug in x1, y1, and m into the point-slope format, and that will be all we need. So since the the x and y coordinates are 3, 5, and the slope is 2, we're going to go ahead and type in, hopefully soon. Again, like I said, there's going to be some sync issues here and there. Y minus 5 equals 2 times x minus 3. Close the parenthesis, and that's it. That's all there is to it. We have a point, we have a slope, we put it in, we plug it in, we leave our y and x, and we're good to go. Now with this next example, we're looking now for a line that goes through 3, 0 and parallel to the line y equals 9x plus 5. So this is a slightly different question, but still kind of the same idea and a little bit of reinforcement with the concept about parallel and perpendicular lines on the coordinate plane. You'll remember that parallel lines have the same or equal slope with the line that you're trying to write. So if it's going to be parallel to the line y equals 9x plus 5, we're going to use the slope of 9 because that's the coefficient of x. So if we write it out, y minus 0 is the y coordinate, and then the slope is 9 times x minus 3 being the x coordinate, and once again that's it. Of course, understand, yeah, y minus 0 does equal y, but because they want us to keep it in point-slope form, we're going to use that format. Now we'll go to the next example here. In this next example now, we're going to be going perpendicular to a line. So if it's perpendicular to a line, y equals negative 8 over 5x plus 2. Remember, perpendicular lines, I know, minor typo there, perpendicular lines have negative reciprocals. We like to say, well, opposite, but also really we like to use the word negative reciprocals. Now, the more official mathematical definition of that is that if they're negative reciprocal slopes, that means that they are additive and multiplicative inverses, which means multiplicative meaning the reciprocal, the flipped version of the fraction, and additive meaning an opposite sign. So we have to just basically flip and switch. Flip the fraction and change the sign. Switch the sign, excuse me. So that means that the slope of this line is going to be 5 over 8. And I'll put my fractions in parentheses in this video and beyond, just to make sure that we isolate. And I'm going to just try to keep using the typing tool. So with a slope of 5/8, because that's the one that's perpendicular to negative 8 over 5, we're going to use the x and y pair coordinates that we have for this, which is 0, 4, and we will write in here y minus 4 equals 5/8 times x minus 0. And once again, yeah, the x minus 0 would simplify to just x, but we'll leave it like that because we want to write it specifically in point-slope form. So now with this one here, this is not too bad, except notice that the x-coordinate is negative, so there's one little minor difference that we do to this. So we'll write out the formula, which is just y minus 2, and then the slope is 7/5 times x. Now it's minus negative 3, but again, one little simplification we like to do here is when we have a subtraction of a negative, we would prefer to write that as addition. So we'll write x plus 3 instead. So y minus 2 equals 7/5 of x plus 3, which makes the sense. Now, I pause here because I mentioned that one of the things I learned in high school as a sort of little shortcut, when I was using point slope form, I would always just think of it as doing the opposite operation, opposite operation of the sign that the x and y coordinate are, but you don't have to worry too much about that. Just kind of go with what it is. Now, in this example is a little different because we have points 5, 8, and negative 2, 7, and our job is to write something in point slope form with that. So for this example, the first thing we need if we're going to use point slope form is we need the slope. So here, because we have 2 points, our job here is to find the slope between those points first. So to do that, we're going to go and write out the slope formula, and we'll write y2 minus y1 over x2 minus x1. So in this case, it's going to be 7 minus 8 divided by negative 2 minus 5. So we'll do that, simplify that out. On the top, that's going to be negative 1, and then on the bottom, that's going to be negative 7. So those would divide, the negatives would cancel out, and we would have 1 over 7, or think of it as negative divided by negative equals positive, but either way, whatever floats your boat there. Now, with this problem here, we actually have 2 possible answers because we have 2 points that are on the line. So it doesn't really matter which point you use, it's just a matter of you using one of the 2 points that are on the line. So in this case, we're going to write out one of 2 possibilities, which is y minus 8 equals 1/7 of x minus 5, or the other way to write it as well is we could write y minus 7 equals 1/7 of x plus 2, and again, because it's the subtraction of the negative equaling adding the positive. So that is all there is for that particular example. So either of those answers would work. And the question, of course, I get is which of the 2 points do you use? Students ask that a lot. They're trying to make sure that they're doing everything exactly as they should, but in that case, you don't have to worry too much about which point you choose. All right, now in this next section, we're going to go ahead and move between forms of lines. So we have here some slope-intercept forms, and we want to convert them to standard form, which you'll remember is ax plus by equals c, where all of our x and y terms are on one side and our constants are on the other. So here, we're going to try to do some handwriting with a mouse, which is never fun. And all we really have to do is, well, if we have something in slope-intercept form and we want to make it standard form, we just have to move the x term over to the other side. So we'll have to subtract 2x from both sides. And if we want it to look like standard form, we technically should have that x term first. You could write y minus 2x, but it's a little more convenient to recognize it's negative 2x plus y. And then, of course, the negative 8, the reason it's negative 8 is because if we're subtracting 8, we would think of it as adding negative 8. So negative 8 would be our c on the left. For b, we have a negative 4 over 7 times x plus 2, and again, we're going to be moving that term over. But since it's negative, we like to take something that's already negative, and we like to add the positive version of it. And yeah, you could subtract negative 4 over 7, but then you're going to be adding, keep change anyway. So adding 4 over 7's x kind of simplifies, or streamlines, I should say, that possibility. And of course, I'm going to add it to this side here, and I'm going to add it to that side as well. I just didn't feel like writing 4/7 x again because mouse handwriting is just painful. So write that out and get 4/7 x, and that's going to be plus y, and that will equal 2. And that's it. That's all you have to do with that. You just have to move the x term over so it's with the y, with its friend, and we keep the number on the left side, we keep it by itself. So we do that, and now we're going to go into the next set of examples. This is the last ones for this video. And here we're going to take something that's written in another form and write it into slope-intercept form, which is y equals mx plus b. This used to be quite necessary a lot because in high school, when we used TI-83 and TI-84 calculators predominantly, those calculators only let you graph functions that were in y equals form. So simplifying it down to y by itself is almost necessary. It's not necessarily as necessary now unless you're still using TI calculators. Some of you may be using Desmos or whatever the case may be. But anyway, how do we do that? So what we do here is we're just going to take the standard form. In this case, example A is a standard form function, and we're just going to get the y by itself. So we think, all right, what operations are happening to y? Well, y is multiplied by negative 7 and then added by 4x. So to undo all of that, we have to subtract 4x first. So we'll go ahead and I'm going to use a thinner pen here. We're going to subtract 4x from both sides. And again, here's our mouse handwriting. Now, when we do the mouse handwriting here with subtracting 4x, it's proper to write the x term first because we think of it as what's called descending degree order. We want our variables as first terms and our constants as last. When we're writing linear functions. So we write negative 4x plus 21, and we have that equaling to negative 7y. And again, that negative, because it carries down, we think of it as plus negative 7y, and then we do that. So then, of course, now the last step is to divide off the negative 7, Now when I divide off the negative 7 here, recall that we want to divide that negative 7 into both terms. When we divide a binomial by a constant, we want that constant, we think of it as distributed into each one. So when we write that out, we simplify it, we're going to have, I'm going to my next text tool in just a second here. I think I must have said it a little slower in the video, in the original version of this video. So we're dividing the negative 7 into both, and then we're going to go ahead and write out y equals, because y is not by itself, and we think negative 4 divided by negative 7, that's positive 4/7 x, and then minus negative 3. Again, because we're thinking of it as plus negative 3, we can write it as minus 3 as well. And I know we flop back and forth between those things, but generally speaking, we like to keep our symbols and operations in conjunction with each other. Not positive numbers should have addition, and negative numbers should have subtraction, as far as subsequent operations. Anyway, last example here. This one's not too bad. This is a point-slope form. Y minus 2 equals negative 5 times x plus 1. So there's 2 steps involved here, just like there were with the previous one. The first thing to do is you got to distribute that right side. Get rid of that parentheses. So we multiply negative 5 by both x and 1. So negative 5 times x is negative 5x, and negative 5 times 1 is negative 5. And then the last thing that we have to do here is we just got to add 2. So we get rid of that, get that y by itself by just moving that 2 to the other side. And our final answer, our final form here is y equals negative 5x minus 3. And that's all there is to it. Anyway, so I hope that this video was helpful for you in getting more comfortable with point slope form. Please like and subscribe if this video, especially if this video helped you. We do upload a lot of math-related videos lately. We have some engineering videos available as well. We are actually just crossed 400 subscribers on this channel, and I'm really excited by what else I can bring to you in the future. Anyway, I hope you enjoyed this video. I hope it helped you, and I hope you have a wonderful rest of your day. And don't forget to be awesome.